Hi guys, today we are going to look at Laravel Scout, which is a first-party package for Laravel, which enables your web apps or websites to have a very fast and efficient Google-like search engine, which is far better at searching data on your apps or websites than what you can achieve using traditional SQL queries, especially if you have massive datasets. I say Google-like search engine because it mimics some of Google's or any mainstream search engine capabilities. Things like typographic error tolerance search, search relevancy, support for synonyms, keyword highlighting, real-time indexing, speed, and much more. Almost all of which is incredibly difficult to achieve using just plain SQL queries. Or even if you manage to do it using SQL queries, it's going to be very complex and almost certainly not as fast and efficient compared to dedicated full-text search providers like Algolia or Meilisearch. In this simple project, we will use Laravel Scout with the Meilisearch driver to create our own mini search engine. I have a couple of thousand movie collections on our fictional movie website called Laraflix. What a creative name. Okay, as I said, there's a couple of thousands of movie here. In order to better appreciate the efficiency and accuracy of Meilisearch as our search driver, I provided a fairly large data for our example. As you can see in my database client, there are almost 10,000 movies here, along with a related table called Movie Casts, which is about 335,000 records. Okay, so here's the demo of our project. So let's try searching some movies. Say Wonder Woman. And now it will return all the movies related to Wonder Woman. We have our first result here, which exactly matches our search term, as well as the second one and the third one. You may also notice that it even searches within the overview attribute and highlights the keywords in both the overview and the title. At the bottom, we can see the number of search results it returns, as well as the total number of pages and the current page you are on. Additionally, there are pagination links so you can navigate to different pages of the search result. This search term returns 112 items. Let's test the pagination. As I click the next button, you can see it navigates to the next batch of results. So let's try searching again. How about Iron Man? Okay, it returns all the relevant results, as you can see. And of course, it also highlights the keywords that match our search term. This search yields 58 results. Let's try to navigate to the next page of results. Okay, it's working well. Now, let me show you one of the benefits of using a dedicated full-text search provider such as Meilisearch, like the one I'm using here. When I type the word house, of course, it returns the relevant results. But watch what happens when I intentionally make a typographical error in my search term. As you can see, even with a typographical error in my search term, it still returns the relevant results. Meilisearch recognizes that this keyword might mean house and still highlights the correct term. This feature is built into Meilisearch and other full-text search providers like Algolia. As I scroll down, you can see that all these results are relevant. And if you notice this one, it guesses that you might also mean that you are searching for a movie called Holes, because the search term is close enough to this one. Meilisearch suggests that you might also be searching for this particular movie title. Let's try another one, say World War, and let's intentionally make a typographical error. Okay, it looks like it's still doing its best to give us relevant search results. Let's try word L. Great, it still recognizes that these movies are what we meant. And this yields 1,000 results. Okay, that's a lot. Okay, that's the demo of our little search engine using Laravel Scout paired with Meilisearch as the full-text search provider. Now let's start learning how we can build this search engine from the beginning. Okay, let's begin working on our search engine. So first, let's install Laravel Scout. From the documentation, copy the installation command for Scout and run it in the terminal. After the installation, let's publish Scout's config files to our config directory. After this, we also need to install Meilisearch on our local machine. So let's go to the Meilisearch documentation to see how to install it. Here's Meilisearch website. Under the installation section, you can see instructions on how to install it on your local machine. Choose the installation steps depending on your operating system. Meilisearch provides installation instructions for almost all operating systems or environments, such as Homebrew for macOS, Docker, various Linux distributions, and of course for Windows. I have already installed Meilisearch on my machine, so let's go back to the documentation to continue setting up Laravel Scout. After installing Meilisearch, we need to add the searchable trait to the model you would like to make searchable. In our case, it's the movie model. So let's hop over to our code editor and open the movie model. As you can see, it's just a typical model file. I have a has-many relationship set up here to fetch all the casts from the related movie. We will also include the movie cast model in our search results so that when a user searches for a specific actor, for example, they can view the movies that the actor is a part of. And we will see how we can do that in a minute. Okay, up here, we will add the searchable trait. And make sure it is imported at the top. Next, let's go back to the documentation. It is also highly recommended to set up a queue driver before using Scout, as you can read in the documentation. This allows Scout to queue all operations related to syncing your models to your Meilisearch indexes. This will provide a much better response times for your app, since building these indexes might take a significant amount of time, especially if you are indexing massive amounts of data. So it's always a good idea to run that operation in the background. So we need to specify in Scout's configuration file to queue indexing related tasks. So let's go to the Scout config file and find the queue setting. Here it is. So by default, it's set to false. And let's set this to true by copying the Scout queue variable and putting it in the environment file. And then set it to true. Okay, I think that's it for this section. Now, in the driver prerequisite section, we need to install the Meilisearch PHP SDK, which is available via Composer package. Copy this command and run it in the terminal to install the SDK. After the installation, to finish the setup for Meilisearch, we need to set up the Scout driver, host, and key credentials within our environment file. Now that Meilisearch is properly set up, we need to start the Meilisearch server from the terminal by running the Meilisearch command. If everything goes well, you should see this output in your terminal. And if you scroll down, you may notice a warning that says, "No master key was found." This is required when switching to production, so it's a good practice to set this up now. Meilisearch thoughtfully generates a secure master key for us. Copy this entire string, starting from the master key flag, and let's terminate the Meilisearch server and restart it. But this time, including the master key flag Meilisearch provides for us. After running this command, you'll see that the warning disappears. And also, let's not forget to include the master key in our environment file for the Meilisearch key variable. Going back to the terminal, you will see that the database path declaration is set to data.ms directory inside the root directory of our project. This is where Meilisearch stores all of the indexes for our search engine. If you check out in the file explorer of our code editor, you'll find the data.ms database directory where our indexes will be stored. You don't have to touch any of these files as they are managed by Meilisearch itself. Now, Meilisearch provides us with a mini dashboard where we can inspect our indexes and even try out the search engine itself. You can see here that the server is listening to localhost on port 7700. If we visit this address, it will take us to Meilisearch mini dashboard in our local machine. You will be prompted to enter the master key Meilisearch gave us earlier. So let's copy and paste it there. Let's refresh the page to see if it's working. Okay, it looks good. Up here, from this drop-down menu, we can inspect all of the indexes managed by Meilisearch. Of course, we don't have any right now. So let's import our entire movie collection from our MySQL database to Meilisearch's index by running this command: PHP Artisan Scout import. Then we need to specify which model we should import. In our case, it's the movie model. So let's import it by specifying the fully qualified class name of the model like this. As you can see, it imported all records from our MySQL database to Meilisearch's index database. So let's go to the mini dashboard and take a look. Okay, as you can see, there's still nothing in the index drop-down menu. The reason for this is that we don't have a queue worker running yet. So the task of importing our indexes wasn't dispatched. Let me zoom in a bit. Okay, let's go back to the terminal and start a queue worker. Before you do this, make sure that you have properly configured a queue driver. Assuming that you are using MySQL as your queue driver, you can simply go ahead and run a queue worker since this is set by default. I'll run the command to start a queue worker. And as soon as you run this, you'll see in the output that the make searchable job was dispatched. This indicates that the indexing task was successfully dispatched. Now, if we go back to the mini dashboard and refresh the page, and there you go. All of our almost 10,000 movie collection was indexed by Meilisearch. By default, Meilisearch will index all attributes of the model you imported. That's why all fields in our movies table are shown here. However, we are only interested in indexing some of the attributes. We can choose which attributes to import to our index to make our search even faster by limiting how many attributes our search engine can look at. We will do that in a minute. But before that, let's try to search for a movie, say Lion King. As you can see, this is almost the same as the preview I showed you earlier. It shows us the most relevant results based on our search keyword, and also highlights the keyword we are searching for in the list of results. Let's try it again, say Captain America. Okay, it looks good. Now that we have our movies indexed, it's time to build our search engine into our fictional website itself. Going back to Scout's documentation, by default, the model was synchronized using a name matching the model's table name. But you also have the option to customize it. And I'm going to customize it by copying this from the docs and pasting it to my movie model class. And of course, I need to rename this to Movies Index. Next, if you want our search engine to only search for specific attributes, for example, only the title of the movies or the overview, you can do that by adding this method to our model class. Here, you can instruct Laravel Scout to only search for specific fields. In my case, I only want to search for the title of the movie for now. We will add the other ones in a minute. But if you want all your fields to be searchable, you don't need to do this step. However, by specifying specific fields to search, your index database will be smaller and your search will be even faster since Meilisearch has fewer indexes to look through. So let's add the original title field to the array like this. Now, when using Meilisearch, it is required to predefine index search settings such as filterable attributes and other options as stated in the documentation. We need to define these settings in the Scout config file under the Meilisearch configuration option. So from the documentation, I'm going to copy this part of the code. Then in the Scout config file, under Meilisearch's index settings array, we'll paste the code here. Of course, we need to change the model class to movies. Let's delete the sortable attributes array since we don't need this for this example. To start, let's include the original title attribute only. Okay, now let's go back to the terminal and re-import our index. Let's check the queue. It looks like the jobs were executed. Now let's go back to the mini dashboard to check the index. And it looks like the other attributes are still being indexed. So let's check what's wrong here. Okay. I think we duplicated our movies index. We have two here in our drop-down menu, both of which have almost 10,000 records. So let's clear the other one first and rerun it to fill the movies index one. I'm going to go back to the terminal and flush the movies index. Okay, this one is flushed, and let's clear the other one as well, since we are going to use movies index with an underscore. In the movie model, I'm just going to change it back to movies. Then flush the index again. If I refresh the mini dashboard page, our indexes are cleared, so let's re-import our indexes again. I'm just going to change it back to movies index, then run the import command again. As well as the sync index settings command. Now after this, it should index the original title for now. Going back to the mini dashboard, refresh the page, and as you can see, only the movie title is indexed. Now to add attributes of your model to the index and make them searchable, all you need to do is include the attributes you want in the toSearchableArray method. Let's add a couple of attributes. You also need to add these attributes to the index settings array in our Scout config file. Next, let's re-import our index and sync the settings once more. After this, you should see all the attributes you want to be searchable from the mini dashboard. If I search something here, okay, it's working fine. After all of this work setting up our search indexes, it's time to integrate this to our app. Triggering the search in our app is almost like querying the database using regular eloquent ORM syntax. But only this time, instead of querying the database itself, we are running our query against our Meilisearch index. Let's create a movie controller where we can add a function for searching. Let's clear all the functions here. In the web.php routes file, I have predefined a search route that points to the search function in the movie controller. Let's create the search function and write the logic for searching. Set search result equal to calling the movie model. And instead of using the where method typical of an eloquent query, we will call the search function provided by Laravel Scout. Then we will search for the keyword the user types in the search input. So let's call it keyword. We will also paginate the results. We have a couple of options for that. One option is the regular paginate function, and the other option is the paginate raw function. Since we are going to use the keyword highlighting in our search results, we need to use the paginate raw function, which includes the original metadata and structure from the Meilisearch engine. And let's paginate the results by 10. And of course, we need to return the result of the search. Let's return it as JSON and put the search result in the result JSON attribute. Now let's go to our search dialog component where we can trigger this function. I have prepared the components already to save us some time, and I don't want this video to be an hour long if I'm going to code this from scratch. As usual, I will include the source code for this project in the video description so you can try it out on your local machine or even modify it to your liking. Here in the search dialog component, under the useEffect hook, I set up a simple debounce feature to delay the code execution when we are typing. As you can see here, I have a delay of 500 milliseconds and a simple debounce state up here. Okay, so let's say when the user types something on the search input field, we are going to call the search function. Let's say axios.post. We will hit the search route, and then we'll pass the keyword as the payload. This will be the search value, and the search value state is binded to the search input field to get whatever we type there. Then when the request succeeds, we are going to store the search results in this result state up here. So say set results, then pass the response.data.result. Well, actually, let's log the response to the console first to inspect the object it will return to us. Okay, let's test it now. Open the browser and go to our project. Refresh the page, and then open the development console. Try to search for something, say Iron Man. You'll see in the console that we have received an output. So this is what we received from our request. And as you can see, it's very similar to a typical response when we make a request with eloquent pagination. We have the data object, the from, last page, next page URL, and other attributes. When we open the data object, we can see the raw data coming from Meilisearch. We have the hits object, hits per page, processing time in milliseconds, our query string, total hits, and total pages. When we open the hits object, this is the result of our search. This is what we display in our search dialog. So when we open the Components tab in React and inspect the search dialog, I am saving the response result here in our result state. So let's go back to the code editor and set our result state. Let's go back to the browser, and you'll see our search results here. Refresh the page and try searching again. Let's say Iron Man. Okay, you can see the results here. And once again, if we inspect the search dialog component, this is our result state. All right, let's go back to our code editor. Let me give you a quick overview of our search dialog. So here is where our search input is located. And further down, we have our search results and the movie list part. So when we collapse this code, all I'm doing here is looping through the results, specifically the hits object to get the results. I'm rendering them in a simple HTML markup. Okay, let's go back to our browser. You might notice that in our search results, we're not yet getting the keyword highlighting feature. The keywords iron and man are not highlighted at all. We don't see any highlighting here, so if we search again, let's try Lion King. You can see that it returns search results, but without the keyword highlighting like in our previous demo. To achieve this, we need to modify the search method in our movie controller. So in the search method, we can pass a second argument here, which is a function. The first argument, let's call it Meilisearch. And the second parameter is the query. Declare it as a string. The third parameter is options, which is an array. Then return the Meilisearch object. Perform a search query again, passing the query variable and the options. For the options variable, specify the attributes to highlight here. For example, set it to the model attributes you want to have keyword highlighting. In our case, we want to highlight the results in the original title, which is the title of the movie, and the overview attribute. So to demonstrate what changes in our response, let's comment out the set results line in our search dialog first. Then inspect the response from our request. Let's go back to our browser and refresh the page. And let's try searching again. Let's say Lion King. In the console, if we inspect the return data within the data object and the hits object, we can see that each result now includes a formatted object right here. When we open this, it appears to be an exact copy of the original response, but you'll notice that in our original title, we have an HTML tags around the keywords that match our search term, which is the M HTML tag. So going back to the search dialog component, here at the bottom is where I declare the formatted response from our request. I'm using dangerously set inner HTML and DOM purify to sanitize the HTML tags returned by our API. This is a good practice to avoid cross-site scripting attacks, or XSS, especially when our API returns HTML tags. I also added a title class to the div container of our result. In the app.css file, I've created the styling for our keyword highlighting. I've added the styles for the title and also for the overview highlighting. So here at the bottom, I also have a formatted styles for the overview attribute. So let's go back to the browser and search again to see the stylings. So first, let's comment out the console log and uncomment the set results function. Now, when we search for Lion King, you'll see that the keyword highlighting in our search results. The words lion and king are highlighted. Each search result now has a keyword highlighting for the relevant keywords like this. At the bottom, we also display the number of search results we got, as well as the pagination details. And of course, there's also a pagination link at the bottom right corner. So let's go back to the search dialog component. Here are the sections of the search dialog: the movie list, search input, and search results. Okay, at the bottom, we have the pagination section here, where we can see the total number of retrieved results. If we inspect the content of the data object, we can see the available properties such as page, query string, and others, since I'm using TypeScript. On the other side, it indicates which page we are on and the total number of pages. And at the bottom, we have the previous and next links. To enable pagination in our example, let's create an on-click event handler for the next button, then call the paginate method. The result.nextpage URL is the URL to navigate to the succeeding page of our results. So let's copy this event and place it in our previous link as well. Instead of the next page URL, we'll use the previous page URL. We need to declare the paginate function at the top, of course. Declare it like this: const paginate. Then as an argument, we'll pass the URL declared as a string. In this function, we will make a request to the URL we passed in. We'll provide it with parameters such as keyword. And remember, search value is what we are searching for. After the request succeeds, we'll set the results to res.data.result. Almost exactly the same as our search request above. Okay, let's try it. Let's go back to the browser. Let's try searching for Lion King again. And you'll see the search results. When we click the next button, you can see that the pagination works. The previous link works as well. So let's try searching for something else, say Wonder Woman. Okay, the keyword highlighting is also working. Great. Now let's try another advantage of using a dedicated full-text search engine like Meilisearch. Let's test the typographic tolerance search. So for example, if we make a spelling mistake in our search, like misspelling wonder, you'll see that it still provides relevant search results. So let's try searching for Wonder Woman with a misspelling in wonder. You'll notice that it still returns relevant results because Meilisearch recognizes that our intended search term might be Wonder Woman despite the spelling error. So now let's try searching for actors who starred in these movies instead of searching by title or any keyword in the overview. So for example, let's search for the actress Gal Gadot. But right now, it's not providing relevant results for the actress we search for. You can see that we only have 2 results here. To enable searching in the related model of our movie model, at the bottom, you'll see the has many relationship that fetches the related casts of our movie model. To enable searching for the related model, we need to add the movies cast has many relationship to the toSearchable method. Then we need to map or loop through the results of our related model in movie casts. In the argument, we'll add a function, let's say cast, and then return the attribute we want to make searchable in the cast relationship. We have the available attributes here. So if we look at the movie cast table in our database client, we can see that we have several columns in our movie cast table. There's the original name, which is the name of the actor or actress who starred in the movie. Then there's the character column, which is the name of the character they played in the movie. So we will return these 2 columns, original name and character. By doing this, we include the actor's original name and the character they played in the movie in our search results. Then we need to cast this to an array. And then the next step is to include the movies cast column in our Scout configuration file under the Meilisearch index settings so that it is included in the indexing. So in the terminal, we need to re-import our movie model. After the queue workers run, we need to sync the settings to include the movie casts in the index. Let's go to the Meilisearch mini dashboard. After refreshing the page, as you can see here, we have our new attribute, movie casts, which is an array. We can see that it included columns, our original name of the actor and the character they played. These data are now included in our search capabilities. So let's test it. Refresh the page and search for Gal Gadot again. Now you can see that when we search with her name, the movies she starred in appear. And of course, we can see that the titles of this movie, if you watch these movies, you know that she is a part of the cast in these films. So if you notice, we have the View Cast button in our search results. My intention here is that when we click the View Cast button, a simple pop-up will appear showing the list of actors who starred in the movie. Let's go back to the search dialog. And at the bottom of our search result, I have placed a list to render the movie casts. Here, I'm simply looping through the data from our response to render the casts. When we go back to the browser and click the View Cast button, a simple dialog will appear showing the actors who starred in the movie. You can see Gal Gadot here. In another result, FastX, when we click the View Cast button, you can see she also is listed here. Another one, Viewcast, and there she is again. So it's not just the original title and the overview that we can search. Using Meilisearch, we can also search related data of our primary model. Let's try searching for something else. Let's say Iron Man. And wait, how about Robert Downey Jr., the actor who played Iron Man? In the first result, he appears in our overview, and in Oppenheimer, there is also a Robert listed, When we click the cast of this movie, we can see a lot of results. Let's check if he is correctly included in the search results. It's a long list, but here he is. This verifies that we can indeed search for cast members, which are part of the related model of our movie. Okay, nice. So now we conclude our video on using Laravel Scout with Meilisearch as our search provider. For more information on the various options and features available in Meilisearch, visit their website at meilisearch.com to learn more. You can also explore additional functionalities on their documentation. In conclusion, Laravel Scout with Meilisearch offers significant advantages over traditional SQL queries, including powerful full-text search capabilities and typo-tolerance. This combination enhances our user experience by delivering more accurate and flexible search results. By integrating Meilisearch, your application can efficiently handle complex search queries, making it a superior choice for modern web development. Okay, that's it. As I said, I will include the project files, link in the video description, including the movies database, so you can try it out if you want. Thank you for watching, guys. See you next time.